Hello, this is Mr. Waters, and this is kind of the second video for this morning about our introduction to sequences. Now, there's another way that sequences are defined, right? And these sequences are that is what's called a recursive definition. So I'm going to write that up at the top here. Recursive. Okay. Sequences can be defined recursively. That is, could be a recursive formula. Okay, so some sequences are defined recursively. What that means is, rather than give a general formula for any term in the sequence, like the ones we're working with before, where s sub n is equal to 2n plus 1, and we can generate the 5th term or the 10th term or the 100th term just by putting that term number 5, 10, or 100 into the formula, and it tells us what number is in that position in the sequence, the 5th position, the 10th position, or the 100th position, right? We give a rule that defines, in this case, for recursive, the recursive definition, we give a rule that defines each term of the sequence in terms of the term that comes just before it. So in other words, I tell you what the first term is, and then the rule tells you what the second term would be. Or if I tell you what the 80th term is, the rule would tell you what the 81st term is. Now, generally speaking, it's an awkward way to define sequences, and normally we're going to use this general rule here, but there are some sequences for which the recursive rule works better than a general rule. Okay, the most famous one being this one here called the Fibonacci sequence. Write it out like that. It's the Fibonacci sequence. Okay, you may have heard of this. Okay, so in the Fibonacci sequence, we start out with 2 ones. And then to generate each subsequent value in this value of the sequence, we add the 2 previous ones. So 1 plus 1 gives us 2. 1 plus 2 gives us 3. 2 plus 3 gives us 5. 5 plus 8 gives us 13. 8 plus 13 gives us 21. And so on, and we could just keep going. Dot, dot, dot. It's an infinite sequence. So the idea of this is that in order to know this term, I have to know what the 2 previous ones are, and the rule is I just add them together. That make sense? Okay, so that's called a recursive rule. That I'm aware of, there is a formula that generates, a general formula that generates terms of this Fibonacci sequence, but it turns out to be a pretty complicated rule, and it's much simpler to give the Fibonacci in terms of this recursive rule. Okay, so how would this work kind of in general? So in order to define a sequence recursively, we would start this way. We would give you the first term in the sequence, then we would give you this rule here. This is the recursive rule here that generates each term in the sequence in terms of the previous number. So this says here that a sub 1, the first term in the sequence, is 2. This says that a sub n plus 1. So that means if n is a term in the sequence, n plus 1 means the next one. So this would be the second term would be 1 plus 1 is 2, right? If we were talking about the 5th term, then n plus 1 would be the 6th term. If we were talking about the 100th term, then the next term would be 100 plus 1, which is the 101st term, right? So let's say we want to generate, like we're doing before, the first 4 terms. Well, we start with the first one, which is n, and that's 2. And then this is going to be a sub n plus 4. Now, rather than just keep putting larger and larger values of n in, we've actually got to put the term, or rather the value of the sequence number in to get the next one. So here the first one was 2, so that's right here. That's the first term in the sequence, right? But then the second term would be 2 plus 4, which is 6. So we put 2 in to get the second term, which is 6. Okay, so now the second term, which is, 2 plus 4 is equal to 6. So now the second term is 6, right? So now how do we get the third term? Well, the third term is the one after the second term. So the second term is 6, right? So to get the third term, we put 6 in and we add 4 to it. So the third term is the second term plus 4, which is 6 plus 4 is 10. To get the next term after that, the fourth term, okay, we start with the third term that we just had, which was 10. So we add 10 plus 4, which is 14. So you see, the idea of it is that we start with the first term and we keep doing something to that term and each subsequent term to get to the number right after it, right? So this would be, so our sequence, by the way, would be 2, 6, 10, 14, ... Right? And so that is our recursively defined formula. Okay, so let's try another one here. How about, let's say that, okay, this will be another example. Let's call this example 2 for recursive formulas. Okay, let's say that the first term, a sub 1, is negative 2. And then each subsequent, then our recursive rule is the next term after that would be a sub n plus 7. So we would start with negative 2, and then this would give us 1 plus 1, which is 2. This would give us the second term. Once we know the second term, that would give us the third term. And once we know the third term, that would give us the fourth term. Each time by adding 7 to each subsequent term. So here's n, the first term, that was negative 2, right? Then the second term, we would put in negative 2 plus 7, which would give us 5. So the second term is 5. So to get the third term, we would start with 5, right, which was the second term, and we would add 7, and that would give us 12. So the third term is 12. To get the fourth term, we would start with 12, and we would add 7, and to get 19 is the fourth term. So up through the fourth term, our sequence is negative 2, 5, 12, 19, ... And you can see that, indeed, each time we're just adding 7, right? But it's the rule is a slightly different format. So this is called a recursive rule. Now, let's do example 3 here. And I'm going to say that what if a sub 1 is equal to 0, and a sub n plus 1, the next term along, would be 2 times a sub n plus 1. Now, put the video on pause here and see if you can generate what the next terms in the sequence would be. Okay, so let's see how that goes. Okay, we're starting with the first term, which is 0. And to get the second term, we're going to take that first term, multiply it by 2, and add 1. So the second term would be 2 times 0 plus 1, which is 1, of course. Now to get the third term, we would start with 1 and multiply it by 2 and add 1. So 2 times 1 plus 1, that's equal to 3. So the third term, as it happens, is 3. To get the fourth term, we would start with 3, or to get the fourth term, we would start with 3 here, multiply it by 2, add 1 to get the fourth term. So 2 times 3 plus 1, that's 7. So the fourth term is 7. If we wanted a fifth term, we just keep doing it. Okay, so we would start with 7. The fifth term, which is this one here, would be the fourth term, which is 7, times 2 plus 1. So 2 times 7 plus 1, that's 15. So that gives rise to this sequence here, 0, 1, 3, 7, 15, and so on, ... Okay, so that's a recursively generated formula. It's kind of awkward to use, but there are some and usually we'll use the general formula where I just tell you what the general formula, but occasionally we'll run into these recursive formulas. So you try a couple of these. So let's say that a sub 1 is equal to 3, and let's say that a sub n plus 1 is a sub n minus 4. Okay? And let's say that, here, you try this one here, let's say that a sub 1 is equal to 4. And let's say that a sub n plus 1 is going to be equal to whatever a sub n is squared plus 2. Okay, try those out. Put your video on pause, try those out, and see how that goes. Now, once we've done that, we're basically done with the formula here with our videos for this morning. I'm going to give you some classwork to try out, plus some homework, which will be due Tuesday after we come back from break. All right? So put your video on pause. Okay, you're back. So the first term is going to be 3, right? And so to get the next term, or rather, the first term, which is 3, we're told that, we're going to put 3 in here. So the second term is the first term minus 4. So the second term is 3 minus 4. That's negative 1, right? Now, what's the third term? The third term is the second term minus 4. So that would be negative 1 minus 4, which is negative 5. The fourth term is going to be the third term minus 4, right? So that's going to be negative 5 minus 4, which is negative 9, right? So therefore, we've got 3. So what's our sequence? Our sequence is 3, negative 1, negative 5, negative 9, ... right? So that is our sequence here. We'll call it a sub n. Okay, this sequence here starts with 4, right? So the first term is 4, right? But then each subsequent term is generated using this formula. So the second term would be 4 squared plus 2. So 4 squared is 16 plus 2 is 18. So the second term is 18. I'm not going to need my calculator for this. So now the second term is 18. So the third term would be the second term squared plus 2. So it's going to be this. So the third term is going to be 18 squared plus 2. So Mr. Calculator says 18 squared is 324 plus 2. So the third term would be 326. So how do we get the fourth term? The fourth term is the third term squared plus 2. So that's going to be 324 squared plus 2. Okay? Or I'm sorry, 326. Sorry. 326 squared plus 2. 326 squared is 106,276 plus 2. So the fourth term would be 106,278. And that's the fourth term in the sequence. So our sequence a sub n would be 4, 18, 326, 106, 278. And if we wanted more terms in a sequence, we'd have to literally keep counting up one term at a time. Okay? And generally speaking, that's kind of inconvenient. And so we usually use the general formula where we can just, use one formula to generate any term in a sequence, like we did in the first video. But there are occasionally they come up. So, for example, the Fibonacci is one where usually the recursive formula is used rather than the general term to generate numbers. Okay. All right, so that's it. Okay, so hopefully that will help. I'm going to generate for you now some classwork and then some homework, which you will find on Canvas. Bye.